Hello and welcome. This is Demetrio Zourarakis, welcoming you to 2020 GS Day at Kentucky State University. It's a virtual GS Day, so I'm pleased to provide two short videos. This is the second one that may help you understand some aspects of your GS careers and challenges like we all have. And we have prepared some slides and some demos, particularly on imagery. This is one of the things that we use every day probably. I want to go ahead and start out our presentation. So the world from above with GIS, and this is the outline of the presentation, and a welcome. Significance of the day across the world, basic concept slides. What does imagery have to do with GIS? We all wonder sometimes that the 3D visualization revolution, which is upon us. I mean, we have been seeing a tremendous progress in technologies with respect to that. Your GIS career will need imagery and other sensor data. If you are not consuming it already, you will be. The UAV revolution, right? Connecting with other professions beyond eye candy. It's all about information, more than just data. Where to find out more, and then a dismissal last night. So GS Day, November 18th, Wednesday, right? We have our GS Day registered. There's a map with events around the globe, and we have, in Kentucky, we have 5, possibly 4. And ours says KSU GS Day 2020. The virtual event will be for connecting high school students, teachers, and other interested learners and practitioners to practitioners of GIS, remote sensing, and the adjacent geospatial sciences. So did you know that the term remote sensing has been in use only since the 50s? And the person who created it was Miss Evelyn Pruitt from the U.S. Office of Naval Research. She created that term to describe the science and art of identifying, observing, and measuring an object without coming into direct contact with it. The process involves the detection and measurement of energy. I made a change on this. It's at NASA, the Earth Observatory says electromagnetic radiation. I think that energy would be better because sonar is remote sensing as well, right? Reflected or emitted from distant objects or materials by which it may be identified and categorized by class, type, substance, and spatial distribution. GIS consumes images of all kinds. They are generated by sensors on platforms, such as satellites, the platform, and sensors could be a multispectral scanner, an imager. Then we have your airborne platforms, fixed wing, or you have your rotor wings, and then you have your unmanned vehicles and systems that have all kinds of sensors on them now, including LiDAR and cameras, of course, but sonar and radar and sonar are also sensors that create images, quote unquote. So what does imagery have to do with GIS? It is geospatial in nature. Through a process of modifying or registering the image to the ground, the image is geospatial, it's georeferenced, and also it can be geometrically corrected, atmospherically corrected, et cetera, et cetera. There's a lot of correction that are done to the image that one takes with a camera from above, and then to create a spatially accurate and precise image that one can use to measure things from. So I'm not a photogrammetrist, but photogrammetry is the science and art of doing that. So the images, when the GIS practitioner or professional gets them is already has a certain degree of accuracy and precision. And now, of course, with the advent of UAVs, there's an elevation measurement that is made and attached to each pixel, of course. So now, how do we use imagery? Well, we have the cartographic backdrop, okay, and that is a contextual. It gives us context. At a map that has only vector data without any images, you see less and less of that. That's an abstraction from reality, and it's more real. I mean, if you have a backdrop with imagery. The digital image for interpretation, digital image interpretation that has been around since World War I and before that. So, so there's a lot of exploitation of the images for purposes of just reconnaissance and surveillance. Surveys of land cover, land use, and infrastructure extract planimetric data from them, from the images. Those are the typical uses. There's a change detection aspect to this. The images will reflect changes in the landscape that precede any actualization of the map of the cartographic products. So we update our GIS with images through information that comes from images. So change detection, data fusion, LiDAR, typical example now, more and more common. I mean, the UAVs and the aerial platforms, airborne LiDAR will capture simultaneously imagery so that there's a colorization of the LiDAR points. And so the product is an image, even though it's pointless, right? Feature extraction using deep learning, artificial intelligence, machine learning, computer vision, etc. There's a lot of tools now off the shelf, ready to be used and exploit imagery. Application to earth sciences such as geology, hydrology, glaciology, planetary sciences. So anyway, imagery has been with us and will be with us for a long time, and the GIS practitioner will consume the data. So it's all about information more than data. Geographic information science is more than geographic data science. So what is an image is made of? It's made of different, it's stored as different bands because, you know, we have different portions of this electromagnetic spectrum that are sampled. So different frequencies and wavelengths. So every band is one color, quote unquote. So we have the typical examples, the TIFF and the JPEG, that have 3 bands. They call true color, RGB, or natural color. But also we have in the world of GIS, we have 1 band images, like the DEM, the elevation models, and the natural normalized difference vegetation index, one of many indices, but it's 1 band. So then you have the multispectral images that have more than 3, but less than about 50, say 10, 15 bands. Those are the typical Landsat data, the Sentinel data, the UAV, and the small unmanned aerial systems capture red edge data. So you have about 5 bands. Hyperspectral imagery has about 224 or more, and those are the typical data cubes that are being used a lot for planetary observations, you know, particularly on mineral prospecting. It's the amount of spacecraft orbiting around the Earth is just, or geostationary, is just ungodly. So there's a ton of data, petabytes, exabytes of data pouring down from space onto Earth every day. So we have different satellites and different platforms, different sensors. Where to find them? Well, one way to find the data is to go to the Earth Explorer. The Earth Explorer contains a wealth of information. Let's see if we can go there. this is the place where you go and download the data, right? So there's different data sets, and the data sets contain Landsat data and Sentinel data. For those of you that have questions on that, we're going to see an example. So you can download, you can download scenes based on the on search criteria. You can use the map, you can use a polygon, a point, you can upload a shape file, etc. So this is the place where I would go if I wanted to download, to pick a scene from a sensor and download it. Okay, and there's now there's not only top of the atmosphere. We don't have time because this is not a course in remote sensing, and there's no time to explain. But we wanna make sure that we know what type of data we're downloading. If it's top of the atmosphere or surface, at surface reflectance data. Okay, so another place is a Globis system, which has been around for a while, and also it has Landsat data, Orview, Sentinel data. So this is an alternative, and you can you can use a slider to choose your different dates, etc. Now, one doesn't have to necessarily download the data. There's services out there, and the typical example is Google Earth Engine. Okay, Google Earth Engine allows you to create code, write some simple instructions that will manipulate the image from a service, and you can choose different dates and different data bands, image bands, to create some indices, or some indices are already pre-calculated, etc. So one needs an account with Google developers as a developer. So then ArcGIS Earth, same thing, same idea. You bring in your multispectral Landsat for different date, for certain date, and then you can bring in some other services. For example, here, Kentucky Natural Color Imagery, or topographic maps, or elevation models, whatever, into this this application, which is, we're going to use it. We're going to use a different one. We're going to use ArcGIS Online and ArcGIS Pro. But this is one of the they can be there's widgets that you can implement and attach to your application. And anyway, Sentinel-2 data and Landsat 8 data are the two data that are the most current in terms of spectral resolution and spatial resolution. Those are very, so it's the 13-band imagery for Sentinel-2. This is an example. There's other satellites, there's other imagery there coming from different programs, and some of them are historic, right? Iconos, for example, right? So you can open the data in Map Viewer or Scene Viewer, so the data can be visualized in 3D or 2D, ArcGIS Desktop or ArcGIS Pro. So imaging on demand. We're going to go in there. We're going to go on. We're going to use our account, our ArcGIS Online organizational account, and sign in. So I can go in here and create a map from scratch. And I'm going to add search for layers. I want to go to ArcGIS Online, Landsat 8 views, and so I'm going to just right here, Landsat 8 multispectral and multi-temporal imagery with on-the-fly renderings and indices for visualization and analysis. Okay, so that's the kicker. So I'm going to just add it to the map, and And then I have my my Landsat 8 image here, and I can I have my Landsat 8 views. I can go in here and say and create a lead, and I can um, an image display. I can choose um, user-defined renderer. So I'm more just use the natural color data will be red, green, and blue. So I know that probably or just let's see, agriculture, bathymetric color, infrared, shortwave, geology, natural color with dynamic range adjustment. So I'm just bringing in images that when I click on the image, it tells me what Landsat scene this is made of. Okay, so this is the Landsat scene, September 18, 2020. Okay, so I'm going to just use a percent clip and apply. And let's see, we get, it should be doing it. Of course, you know, there's always communication. There you go. That is the natural color for downtown Frankfurt. You know, 30-meter pixels, but I can change this to color infrared image, and we have now a I'll use a standard deviation stretch. So where the vegetation shows red, I'm feeding the near infrared band on the red channel, so it's doing it hopefully. And anything that looks like green or gray or blue is the built up or barren. The river looks like that because it's brown, right? I mean, it has soil, sediment, suspension, etc. So I'm bringing in my my data from my. So I'm going to add the Sentinel data now. I'm going to search for layers again, and I'm going to just Sentinel to views, and add it to the map, and so you can see the differences in spatial resolution. And of course, the spectral resolution also is higher. So that's Sentinel data, right? So I can go in here and Sentinel data, I'm going to turn Landsat data off. And on image display, again, we're going to just see color infrared, bands 8, 4, and 3, red, green, near infrared, red, and green, which is a canonical way of applying it. This deviation, dynamic range adjustment, because it's going to take the data. And so now we have this, right? We have two satellite data, and there's a difference, right? There's quite a bit of difference there. So you can see more things, and you can extract information from this. All right. So we have done that. So career connections with imagery in GIS. Imagery would allow you to connect with other careers. For example, of course, coming from the practitioner of GIS, a professional GIS realm, the typical applications are earth sciences, geology, hydrology, glaciology, you know, all kinds of geohazard analysis, earth sciences, forestry, agriculture, land surveying, engineering, building information models, the outside of buildings, right? And the inside now. There's all kinds of surveys that are done automatically that connect images with LiDAR, emergency response, homeland security, military intelligence. Those are the native, those are the natural applications of imagery. For example, here for agriculture, we have the shows false color Landsat 8 on the irrigation pivot, center pivot irrigation. And then, of course, we have here the images that show yield map on the right, and then you have some elevation data, lidar survey of the image uh, that influences crop yield. You can fly a drone, or you can take satellite imagery to monitor your crops from space. So precision agriculture, consuming images in a GIS. Imagery on demand. We can use ArcGIS Pro and ArcGIS Online to bring in high resolution imagery. So one way to do this is to go in here and let's see if I can do this. Add a layer from the web, and let's see. Let's see. I'm trying to do this layer from the web. I guess server. It is a server web service. The best way to go about this is to find out on Kentucky from above. There's aerial imagery, high resolution aerial imagery, and it can be okay. Okay, for example, this. For example, NAPE 2018 2-foot, right? So what we're gonna do is we're gonna just see if this works for us. My map there. And this is now 2018, right? 2018 4 bands. So I'm gonna just create a false color infrared band for the summer of 2018, and then I'm gonna just stretch percent clip and then dynamic range adjustment. So basically, this is apply. This is the type of thing that we see: aerial imagery and imagery from space, right? Different days. Sentinel, okay, that's at Landsat 8, and then 1 of 2, 5. Okay, so Copernicus. Okay, so November 2020. This is the date for the Sentinel data. Okay, so very important. There's metadata behind all the imagery. So in ArcGIS Pro, the way it's done is also it requires to discover it through the portal that goes to ArcGIS Online. So I'm going to just create a new map, and then on portal. Oops, sorry. Just go here, ArcGIS Online, and Landsat 8 views, and views, and adding the data. So there's different ways of adding the data. I don't have to download anything, really. If I know what scenes are brought in now we're experiencing a little bit of a delay here, but there's all kinds of derivatives here you can see on your So it's a matter of connections, right? Now I'm consuming the data from ArcGIS Online, and I'm trying to hit the same data service, image service from ArcGIS Pro side. So anyway, it doesn't. Okay, there it is. That is the whole world. It's gonna paint it. It's gonna be the whole world, and then you know, you can. So there you go. That's a path and row. The scenes are, and anyway, it's more than just images. Okay, I mean we can analyze. We can take a lot of take the information that contained in these bands and extract some information on vegetation, on infrastructure, on linear features, on all kinds of things. So so there's not enough time on this presentation to do that. So we have image services, we have ArcGIS Online, ArcGIS Pro as well, high resolution, etc. So further resources for imagery and GIS. We have Earth Explorer, we have Kentucky from Above, the image services and elevation services that can be used together to see some change detection, because remember the clock ticks differently for LiDAR acquisitions than it does for image acquisition. Okay? A commercial software example, for example, ArcGIS Pro, the one I use, but Airless Imagine and MV, many others, commercial packages are specific for remote sensing and GIS. I mean, you do need a GIS to consume remote sensing products. Then we have open source software, for example, QGIS and Multispec are perfectly free, absolutely free, and you can manipulate imagery and extract information. So we have not touched upon image classifiers and deep learning, but there's a ton of tools that exist to extract different classes, different objects from images, not just pixels, okay? So, but there's not enough time on this presentation. So if you have any questions, just after this GS day is over with, you know, we are here to help, and you know how to contact us. So have a great 2020 GS day and beyond, and good luck in your careers. And thank you so much for your time.